Okay, so I've had to move on to the big whiteboard because I'm now going to integrate sine to the 6x again, but this time using what's called the reduction formula. And ironically, the reduction formula makes everything huge. In terms of sine to the 6x, we're going to get lots of terms. So what we start by doing is we start by introducing general integral in, where n is the power of sine n of x dx, and then we take out a factor of sine x inside, so we end up with the integral of sine x multiplied by sine n minus 1x dx. And as you can see, that now becomes a product, and if it's a product, we can use the integration by parts. So we're going to say that u equals, well, since we are trying to integrate a large power, logically we're going to use u as sine n minus 1x, and therefore we have to differentiate that using the chain rule. You can do that on the side. I'm just going to go straight ahead and differentiate. So it becomes n minus 1 multiplied by the function sine n minus 2x, and then multiplied by the derivative of sine x, which is cos x. Okay, and then we're going to use sine x to be our dv dx. So if I put dv dx here, that's going to be sine x, and therefore v is equal to cos differentiates negative sine, so that becomes negative cos x. So we've got all our components for integration by parts. So my integral in now becomes uv, which is equal to u times v negative cos x multiplied by sine n minus 1x. Subtract the integral of v du dx. So v times du dx, so it's these two multiplied, because that's negative, that becomes plus. We're going to take our n minus 1 outside here. Integral of cos x times cos x is cos squared x multiplied by sine n minus 2x dx. As you can see, we've already significantly expanded our original integral. Now we're going to substitute 1 minus sine squared x in place of our cos squared x, and see what happens. So our integral now becomes equal to negative cos x times sine n minus 1x plus n minus 1 times the integral. If I replace cos squared x with 1 minus sine squared x, I get sine n minus 2x, subtract sine squared times sine n minus 2 just becomes sine nx dx. Okay, so we are now going to multiply everything through by n minus 1. So it becomes in equals negative cos x times, I'm getting a bit bored of writing this now, I should probably use some shorthand, times n minus 1. The integral of sine n minus 2, I'm now going to just call n minus 2 for simplicity. And likewise, I'm going to write minus n minus 1 times in, which is actually what we're after. Okay, so luckily that's shrunk down a little bit. If I expand this out, I get minus n negative negative plus in on the right hand side. In obviously is what we're after, negative cos x times sine n minus 1x. And if I multiply this out, I've still got my plus. I'm not going to multiply that, I'm going to leave it as that. Okay, what you should hopefully notice right now is we've got in's on both sides, so they cancel. This is what we're after. I'm going to bring it onto the left hand side. This is 0 now, so it becomes n in, and we're getting close to being to a point where we can stop. sine n minus 1 x plus n minus 1 I n minus 2. Okay, so there's one last thing we need to do to establish what my general integral of sine to the nx is, and that's simply divide everything through by n. Okay, so that becomes in is what we're after, is negative 1 over n cos x sine n minus 1x plus n minus 1 over n of the integral of in minus 2, or the integral of n minus 2. So this is our general reduction formula. I'm going to start again on a new board so that we can actually use that to finally integrate sine to the 6x. Okay, so quick reminder where we got to. In, the general integral of sine to the nx, is negative 1 over n cos x sine n minus 1x plus n minus 1 over n multiplied by the integral of sine to the n minus 2x. So in this case, we set n equals 6. So our integral we're after, so this is actually I6, the integral of the 6th power of x, is going to be equal to negative 1 over 6 cos x, no dependence on n, sine n minus 1, so it's sine to the 5x, plus n minus 1, which is 5 over n, 5/6, I n minus 2, which is I4. So you'll notice we've now got a reliance on the 4th power integral of sine x, but we can once again use a reduction formula. So here we've set n equals 6, now we can set n equals 4. So now we've got I4 is equal to negative 1/4, 1 over 4, cos x multiplied by sine n minus 1, so that's cubed x, plus n minus 1 again is 3 over 4, so 3/4 I n minus 2, so this is r squared power, I squared. Now we're going to set n equals 2, so we get I2 is equal to negative 1/2 cos x, that becomes just multiplied by sine x because it's n minus 1, so 2 minus 1, plus n minus 1, which is 1 over 2, so it was 1/2 I2 minus 0, I0. And we reach an end. Now, what is I0? Well, I0 is, by definition, the integral of sine to the 0x. And sine to the 0 is just 1, so I0 is simply equal to 1 integrated, which is just x. So now we've just got to plug everything back in order, okay? So I6 is what we're after. So we're going to start here and work our way down, putting in our varying substitutions. So we've got negative 1/6 cos x times sine to the 5x plus 5/6 times I to the 4, which is this thing, which is negative 1/4 cos x times sine cubed x plus 3/4 of I2, which is going to be equal to this thing. You can clearly see why I needed a large board for this monstrosity. So that's cos x sine x plus 1/2 I0, which is 1/2 times x. Oh, just about squeezed it in. Okay, and we can now go ahead and expand and, fingers crossed, simplify a little bit. So sine to the 5x, 5/6 times this is negative 5 over 6/4 are 24. Okay, cos x times sine cubed x. Be careful here because we've got to multiply this by this by this. So 5 times 3 times 1 is 15 over 24, 15 over 48, and it's negative. And that's going to be cos x times sine x. And then we've got the same thing again, but this is now positive, plus 15 over 48x. So I'm thinking we can probably simplify that a little further. So finally, I6 is equal to negative 1/6 cos x times sine to the 5x. 5 over 24 does not simplify, so it just becomes the same cos x sine cubed x. And then both of these divide by 3, so that's 5/16 cos x sine x. And that also divides by 3, 5/16 x. Okay, I can plus c in because I can just about fit that. You'll notice that this integral doesn't actually look like the same integral we did using the de Moivre's theorem identities. Actually, they do look the same graphically. They're just presented in different ways. So you probably have to trust me on that. Okay, so there is the reduction formula.